Hi, I'm Pagra12. Happy New Year to all of you. Today we play with tentacles. This is my first tutorial for this year. And I've been playing a lot with this, and I would like to share with you my idea. So we can build this octopus like something and have here a lot of parameters to play with. For example, the count would give us the number of the tentacles, okay? And the step is like the smoothness, and we can go higher with this and we get those snakes, or we can go smaller and we have those segments, okay, which they each have a nice round cap, okay? The radius and the speed, obviously, and a lot more actually. And yeah, let's do this. I will leave this aside. And first, I would like to have a little drawing here to see what we're gonna do. And let's imagine we have 5 points, okay, so randomly. And I would like to build tentacles with those points. And my question is where should be the center? And yeah, the center, it might be the average of all those points. Okay, let's imagine it's here somewhere, okay? And okay, let me pick the red color, okay? And now we have to interpolate points on those lines, okay? So if we put here 4 points, for example, on each, or 3, doesn't matter. Then we use a cylinder, okay, and with the right length, okay, and we'll connect each 2 neighbor points, and with good orientation and so on. And this is the main idea. Now let's go and build this. So what we need is a constant chop, okay, and let's see, we need count, okay, let's go with I don't know, maybe 12. We need the steps, let's go with 16. Okay, radius 0.0125. Okay, and what else? Divisions. This is for the how smooth the cylinder is. Let's go with 24 for now. And last one would be speed. And maybe 0.0625. Okay, now we use a null here. And in between, insert a null. We click outside, collapse selected, go inside and delete this null. We make 2 branches here with select chop. Okay, in first one we go with count and rename it into map. And now we use mat chop and go for a root and ceiling. Okay, here we use merge. Okay, and here in the second select we take speed, rename it into time, and now we connect speed chop, and now we have the time. Okay, let's see. So we need a texture. We use a noise stop, and we take the map for the resolution. Okay, nearest pixels 32 RGB and not monochrome. And here we have 16 points. We only need 12, and so here in the palette point clouds we drag point repack, and we connect this, and for the resolution we go with count by 1, and here we have the points. Okay, now I would like to see them, so let's have a sphere like this, and we go for we use a transform and use the radius for uniform scale, and now a geometry. Okay, let's go here with instancing, and we use this texture RGB. Let's make this texture pink, and here position. Okay, now let's split this. Okay, and here we have the points. Okay, now to find the center of those points we use analyze here. Okay, and we got it. This is the center point, and you can see it's somewhere here. Okay, and now I use fit, and I'll go with count for the resolution X and 1, nearest pixels, and fit fill. Okay, and now if I use layout like this, I'll have both of them in one texture, so the center and the points. Okay, let's go with custom resolution, and we go with count by 2. Okay, and we need to say output aspect resolution, and here would be top to bottom and nearest pixels. Okay, so now we have the center and the point on each column. Okay, in order to interpolate in between them we use resolution top, so here resolution. Okay, let me make a little room here like this, and let's open this. Okay, right here, and now in the resolution we go with the custom resolution. We drag the count here for the res X, and the steps divided, not divided, multiply by 2, sorry. Okay, we take resolution for output aspect, and here in the input smoothness we leave it like this, and viewer smoothness nearest pixels. Okay, now you see we have a bunch of points like here, and now they are a little too many. Okay, since at the bottom and at the top we have duplicates. Okay, now we use group, and let's take nearest pixels. Okay, and here in the group on top and bottom I'll take pixels, and I drag the steps in the bottom and use steps divided by 2. I copy this, and here I paused, but I change divide into multiply, so it's steps multiplied by 2 minus steps divided by 2, and now we good. Let me check if on some smaller, not even number, or So let's go with 5. Okay. Now you see we have this ugly gap. Let's check the texture. Okay, so this row and this row, it's quite similar. Okay, and this is because here we have 2.5 and 7.5 for the pixels. And what I do now, it's I'll take one of them floor and the other one ceiling. So mat dot floor parentheses like this, and here I go with mat dot sail. Okay, and yeah, now we have 5 points on each. Very nice. Okay. Okay. Now let's put a tube there instead of the circles. Okay. Don't worry of having this those points not in the middle. In order to see the pixels, we work like this, and then maybe at the end we offset to center everything. Offset to center. So okay, let's have a tube now, and this one should be on z-axis. Okay, polygon, we don't need rows. Divisions goes here at columns, and radius here. And let's have a look now. Okay, the tube has to stay. We drag the height here into center Z and divide it by 2, and now we have a good tube. And we don't need another geometry, we have it here, so let's connect this. Now we have a bunch of tubes, and nowhere the right length. Okay, and yeah, let's do that. Okay, so I will use null here in order to make some branches. Okay, so here I have the positions, and now I will build a texture for the scale. Okay, and what I can do, I use transform here. Let's have a look. Nearest pixels. In order to compute subtraction between this point and this point, we need to offset this texture 1 pixel. So I go here, I use pixel and maybe -1. Yeah. And now here on the second tab we go with hold, and we use subtract, we connect those two, and now we use mod. Here we go with length, mask alpha, 32 mono. Okay, and let's use a null. This one is scale. Now obviously we have only the scale on Z right now, and yeah, let's see. So if I drag this, let's use red for Z. Now we have a good scale for each segment. Okay, and we need to orient each segment where the next point is, and we already have that. So we color this texture sub 1, and we drag it here into the second tab. Okay, RGB, and we take any other option here. So now we good, and yeah, what if we make those points moving a little bit? So we drag the time into the transform, translate Z here, okay? And yeah, it's good. I would like to have this much more dynamic, okay? And I can use here, okay? I can use a noise. So I will noise the center point according to its position, okay? It will not stay the center, the new center will walk around. So not monochrome input, okay? And yeah, let's see. Okay, now the center goes nice. Maybe too much, maybe 3 to 5, it's good. And what else? Okay, I would like to make each cylinder smaller, thinner, as it approach the tip, okay? And I can use a ramp for this, okay? And in order to make this ramp the same resolution with everything else, I can connect this point. And let's go with 32 mono, and here is vertical, okay? Now, if here in this texture I have the center to the bottom, and obviously in this interpolation, the bottom is the center. Now, obviously I need to invert this, and I'm using a level for this. So, okay, we go invert. This is good. Now, I use a reorder, and this value goes for X and Y, and this one here for Z. So I connect here. I make this 32 RGB, and blue is input 2. Okay. Now let me make those 3 nearest pixels. Okay. And we need to fix something, since now the scale is taking only red, and it should be R, G, and B now. Okay. Now let's increase the radius a little bit. So we have this star, and it's not quite an octopus, okay? But what we can do now is here, right after the group, we noise again all the points. So I'm using the same noise, copy paste. I connect those inputs, both of them. And yeah, let's make this nearest pixels and put it here. And now, yeah, something happened, okay? Now let's modify this a little bit, maybe 0.2. And yeah, like this. Now you can put the end caps here for the cylinder, okay? And yeah, you see the caps now, and this is something, it's less visible if the steps are it's a big value. Let's go with 64, okay? But still, when we have an angle between two segments, you can see the caps. And here I wanna put a sphere, okay? For this, I will go down with the steps, okay, like this, and maybe only 4, okay. Now I already have this sphere here, okay? I will copy this geometry and I'll connect. Okay. Now, yeah, I see something, the green, and I wanna make this geometry a little bit transparent. So I use not a constant, a Phong maybe. So I use a phone here, and I'll go with alpha a little bit down, and here blending. Okay, now I can see my spheres, and they are bad because right now they're taking a different scales, and I should have here R and R. Okay, now yeah, we good, almost. Okay, those nasty you know, edges when that cylinder intersect with the spheres, we can correct that, and let's have a look here. So this sphere, okay, it should be 24, and here 24 divided by 2. Okay. And it has to be oriented to the z-axis, and so I use transform here, not trace, sorry. Okay, so I can transform and rotate this 90 degrees on X, and now let's check. Now I'm good. Okay, and now it's much better. Okay, but let me pause a little bit, so I will set the speed on 0. Okay, now let's have a look closer. I have the spheres, and they only need a little bit a bigger radius, and they need the same radius as the thicker cylinder for every joint. Okay, and what I can do, I just offset their positions. Okay, so I select. Okay, I select these texture positions. Okay, and I make another one. Okay, I make it pink. Go here to replace that, and now if I use a transform, and let me put nearest pixels, I can offset this one, not one. Let's check -1, and now we good. You see, and now the intersection of the cylinder with the sphere, it's much nicer. Okay, so yeah, let's make this move. Okay, and now we can take the transparency off. Okay, I use the same material for the spheres. Okay, and yeah, let's increase those a little bit. Okay, so yeah, you have this yeah, octopus like something, and let's see how we can color this. This tutorial is not about texturing and colors and so on, but even though we don't render this out, yeah, let's put some colors here. So here we have the positions. Okay, now everything is working. Okay, and I can offset this to 0 now, and yeah, here are my points. I can't use point position for the colors right now. as it will look a little bit dark. So what I can do, let's use a null here, and I make this one also pink, and yeah, maybe this one is color. Okay, and I use a mod. Okay, and my values here are let's say, so I rearrange this from -1 to 0, 1. Okay. Okay, and now let's see if I use for both geometries for the colors. R, G, and B. Yeah, we have this, and maybe you like it as it is now, or what I like to do to not have those position colors. Okay, and yeah, having a couple of other settings to play with, I like to use a noise here, and I'll take the second input from my point position. Okay, and now let me put this the same resolution, so it's 16 by 32 right now. Okay, 32 RGB, and yeah, let's see now. And now we have some colors, and if I scale down to 0.2, and yeah, now you change the seed and play with those parameters, and you can find a lovely color, maybe. Yeah, and this was my tutorial. You can play with this. Actually, here in this noise, if you play with the harmonic, it's like the tentacles will go way long, or yeah, you have to experiment with this. Is very nice to play with. Okay, this was my tutorial. I really hope you like this. Subscribe, hit the like button, comment below, or you can support me on Patreon. You'll get access to a bunch of other tutorials, and you'll help me going out with my research. Thank you so much. A big thanks to all my patrons.